standing amid a modern Asian metropolis. Glass and steel skyscrapers, complex LED lighting systems, and cutting-edge digital technology surround you. Now imagine traveling back just a few thousand years. The scene before you would be completely different. No modern machinery, no towering cranes, no 3D design software, not even the basic tools we take for granted today. Yet a remarkable paradox emerges. While many modern structures are designed with lifespans of merely from 50 to 100 years, Asia's ancient wonders have stood firm for millennia. These monuments have witnessed the rise and fall of countless dynasties, endured innumerable earthquakes, floods, wars, and still remain to tell their astonishing stories of human civilization. When discussing ancient world wonders, many immediately think of the traditional list of 7 wonders concentrated in the Middle East and Mediterranean: the Great Pyramid of Giza, Hanging Gardens of Babylon, Temple of Artemis at Ephesus, Statue of Zeus at Olympia, Mausoleum at Halicarnassus, Lighthouse of Alexandria, and Colossus of Rhodes. Notably, among these, only the Great Pyramid of Giza remains standing today. But vast Asia, cradle of many of humanity's oldest civilizations, has left us a richer and more diverse architectural heritage. From powerful Eastern empires to Hindu and Buddhist kingdoms in Southeast Asia, from complex Middle Eastern civilizations to expansive Central Asian empires, Asia has produced architectural achievements that are not merely beautiful, but contain countless mysteries and questions that modern science still strives to decode. Have you ever wondered, how did ancient civilizations construct such magnificent structures without modern technology? Why do many of their creations still stand after thousands of years, while our modern buildings have much shorter lifespans? What secrets of ancient building techniques remain undecoded by modern science? In today's exploratory journey, we'll not only admire the formal beauty of Asia's 7 wonders, but also delve into the hidden stories behind them, the technical challenges faced by ancient builders, the breakthrough technologies they developed, and the cultural, religious, and strategic significance of these structures. You'll understand why these structures aren't merely architectural achievements, but testaments to the creativity, perseverance, and extraordinary vision of ancient Asian civilizations. The Great Wall, stone dragon winding through millennia. From space, the largest and longest human-made structure on our planet is the Great Wall, a colossal stone dragon winding through mountains, valleys, and plateaus of the northern regions. Stretching over 13,000 miles from east to west, this isn't merely a wall, but a complete defense system with more than 25,000 watchtowers, 15,000 fortresses, and countless garrison stations, storage chambers, and many other supporting structures. What makes the Great Wall truly unique in world architectural history is its construction process spanning multiple eras. The earliest sections began to take shape in the 7th century BCE, when small states during the spring and autumn and warring states periods built earthen walls to protect their territories. However, most of the structure we see today was built during the from 14th to 17th centuries, when the empire faced continuous threats from northern nomadic tribes. Can you imagine? This extended construction project employed over 8 million people across many centuries. According to recent statistical analyses, an estimated from 2 to 3 million people perished during the wall's construction, earning it the title World's Longest Cemetery. If all the stone and brick used to build the Great Wall were formed into a wall 16 feet high and 3 feet thick, that wall could encircle Earth's equator. Technically, the wall was constructed primarily using rammed earth, brick, and stone, depending on locally available materials. In the most challenging regions, ancient builders had to transport materials to elevations exceeding 5,000 feet above sea level, traversing steep slopes and dangerous mountain passes. They used rudimentary pulley systems, carts, and pure human strength. One of the most impressive technical secrets of the Great Wall is a special mortar used to bind the bricks together. Recent scientific studies have discovered that this mortar's components include lime, clay, fine sand, and, surprisingly, sticky rice. Laboratory tests show this rice mortar has superior tensile strength compared to modern cement under certain conditions, particularly in crack resistance and adaptation to extreme temperature changes. from -40 degrees F to 104 degrees F, characteristic of the northern border region. Modern material scientists have discovered that the amylopectin protein in sticky rice is the key to this ancient mortar's remarkable durability. When analyzing mortar samples from different age wall sections, they found this organic compound forms a nanoscale network structure, combining with inorganic minerals to create an extremely durable composite material. Interestingly, despite thousands of years of weathering, this nanostructure maintains its integrity in many sections of the wall. But the Great Wall isn't just a military and technical marvel. It's also a complex transportation and communication system. The top of the wall is about from 16 to 26 feet wide, enough for 5 horsemen to gallop side by side, or 10 people to walk abreast. The watchtower system served not just for defense, but as relay stations for a sophisticated signaling system using smoke, fire, and flags that could transmit messages along the wall at an astonishing speed. A message could travel over 470 miles within just 24 hours, a communication record for ancient times. Did you know? The Great Wall is actually an aerodynamic engineering wonder. Researchers have discovered that many wall sections were designed to create special aerodynamic effects. When strong winds blow through mountainous areas, the wall creates unique airflow patterns, generating natural warning sounds during unusual strong winds, an early warning sign of bad weather or approaching armies. Recent archaeological discoveries have revealed that a sophisticated sound tunnel system exists along the Great Wall. At certain strategic points, ancient engineers created special hollow chambers within the wall structure, allowing distant sounds, like the hoofbeats of invading cavalry, to be amplified and transmitted, functioning as a natural early warning system, requiring no energy. This ancient acoustic technology is still being studied by modern scientists for application in natural disaster warning system design. Today, standing on the Great Wall and watching it wind endlessly to the horizon, we're witnessing not just a magnificent architectural structure, but evidence of the vision, perseverance, and extraordinary intelligence of human civilization. This stone dragon didn't just protect an empire, it connects past and present, bridging ancient technical achievements and modern technology. Petra, rose-red city carved into mountain walls. From the layered mountains of the east, let's travel westward to the arid deserts of the Middle East, home to one of humanity's strangest architectural wonders, the ancient city of Petra. Known as the Jewel of the Desert, Petra was once a thriving trade center of an ancient Arab tribe known for their remarkable architectural and hydraulic engineering skills. What first makes Petra unique is its unparalleled approach. Surrounded by high rock walls and accessible only through a narrow gorge, 0.75 miles long, called the Seek, Petra is a virtually impenetrable natural fortress. The Seek isn't just an ordinary passage. It's a deep canyon with rock walls towering up to 260 feet on both sides, creating the sensation of passing through a time portal into another world. Emerging from the Seek, the scene that greets visitors is breathtaking. Al-Khazna, or the Treasury, a 130-foot tall architectural structure carved directly into the rose-colored sandstone cliff. With its Corinthian columns and intricate ornamentation, Al-Khazna represents a perfect example of the fusion between classical Greco-Roman and indigenous desert architectural styles. Did you know that Petra wasn't built, but rather carved, directly from the mountain? Unlike most ancient cities built from the ground up, Petra was created by removing material from the rock face. The artisans worked from top to bottom, carving into the sandstone cliff, removing unnecessary rock with astonishing precision. Recent 3D computational analysis shows tool marks on the rock surfaces follow an organized pattern system, suggesting the existence of an advanced design system and systematic implementation process. The latest laser scanning studies have determined that Petra's structures were designed with remarkable mathematical precision. The golden ratio, 1 to 1.618, appears repeatedly in many structures, and modern acoustic tests show many buildings were designed with sophisticated acoustic calculations, creating special sound effects suitable for religious ceremonies. In the Great Theater, a whisper from a specific stage position can be heard clearly in the last row, nearly 100 feet away. Al-Khazne is just the beginning of Petra. Venturing deeper into the city reveals a complete urban complex with over 800 rock-cut structures, including temples, tombs, a theater holding 8,500 people, and an elaborate system of streets and plazas. Many structures contain complex room and corridor systems inside, sometimes extending hundreds of feet into the mountain. Most impressive about Petra is its sophisticated water management system. Located in an arid desert region with annual rainfall of only about 6 inches, Petra could not have supported a populous city with 30,000 inhabitants at its peak. However, the ancient builders developed a complex system of dams, reservoirs, and water channels to collect, store, and distribute water. Modern hydrological studies show they created a system of 200 reservoirs with a total estimated capacity of about 8 million gallons of water. The channel system, extending over 75 miles, was designed with precise gradients to maintain optimal flow rates, and the Seek itself was transformed into a massive spillway, with dams and flood channels ingeniously constructed to protect the city from flash floods characteristic of desert regions. Chemical analysis of water cistern components shows the ancient builders used a special mixture of fine sand, lime, and volcanic ash to create an effective waterproof mortar. Surprisingly, this mortar has self-healing capabilities for small cracks when in contact with water, a feature that modern materials scientists are trying to recreate for sustainable building applications. But do you know Petra's greatest secret? This vast city was completely forgotten by the Western world for nearly 500 years. After the Roman Empire declined and trade routes changed, Petra gradually lost its economic importance and was abandoned. Only local desert nomads knew of its existence until 1812, when a European explorer disguised as an Arab merchant was led to this forgotten city. How many more ancient wonders might be hiding beneath desert sands, waiting to be rediscovered? Recent archaeological studies using ground-penetrating radar, GPR, have detected hundreds of unexcavated structures beneath the surface around Petra, suggesting the city was actually much larger than the excavated portion. A notable 2016 discovery was a massive structure, the size of an Olympic swimming pool, buried under sand with a large stone platform and a staircase leading to a ceremonial platform. The exact purpose of this structure remains a mystery. Today, when admiring this mysterious rose city, we not only appreciate its architectural beauty, but are astonished by the technical talent and extraordinary adaptability of its builders, who transformed a harsh desert environment into a thriving urban paradise. Angkor Wat, gigantic temple city amid tropical forests. From the arid deserts of the Middle East, let's journey to the lush tropical forests of Southeast Asia, home to one of the world's largest and impressive religious monuments, the Angkor complex. This isn't just a single temple, but a complete religious city spreading over 400 square kilometers, larger than modern Paris. At the center of this complex is Angkor Wat, a temple built in the early 12th century. Initially constructed as a Hindu temple dedicated to Vishnu, Angkor Wat was gradually converted into a Buddhist center in the late 12th century, reflecting the changing beliefs of the kingdom. Did you know that Angkor Wat is the world's largest religious monument, covering 820,000 square meters? For comparison, it's 4 times larger than Vatican City. The main structure stands 213 feet tall, equivalent to a modern 20-story building. More importantly, the entire complex was built without cement or mortar. The stone blocks were cut with extreme precision and fit so tightly together that it's impossible to insert a knife blade between the joints. Angkor Wat was designed as a microcosmic model of the universe based on Hindu cosmology. Its 5 lotus-shaped towers symbolize the 5 peaks of Mount Meru, the mythical mountain where deities reside. 3 concentric galleries represent the mountain ranges surrounding Meru, and the surrounding moat represents the cosmic oceans. This arrangement transforms the temple into a 3-dimensional cosmic map, where pilgrims could undertake a spiritual journey from the earthly realm to the divine. Recent digital archaeological studies have revealed that the entire Angkor Wat complex was constructed based on a sophisticated measurement system using the HAT unit. approximately 17 inches. Every distance, height, and proportion in the temple complex is an exact multiple of this unit, with errors of only a few millimeters, despite construction over a vast area. This demonstrates the existence of detailed architectural plans and a complex standardized measurement system. Particularly impressive is Angkor Wat's astronomical alignment. Modern studies have identified that the temple has astonishingly precise astronomical alignments. During the spring and autumn equinoxes, the sun rises exactly over the central tower when viewed from the western causeway starting point. Furthermore, 12 towers in the complex are arranged corresponding to the 12 zodiac signs, and distances between main structures reflect lunar, solar, and planetary cycles. The stone bas-reliefs at Angkor Wat are a priceless treasure trove of art and knowledge. The longest relief, extending 39 feet, depicts the churning of the ocean of milk, a Hindu creation story. Other reliefs illustrate stories from epic poems and historical events of the kingdom. In total, Angkor Wat contains over 12,900 square feet of carved bas-reliefs, with thousands of figures depicted in astonishing detail. A little-known aspect of Angkor Wat is its sophisticated acoustic design. Researchers using sound simulation technology have discovered that corridors and main chambers were designed to create specific acoustic effects appropriate for religious ceremonies. At certain locations within the temple, chanting sounds are amplified and reflected in ways that create complex harmonic effects, enhancing the spiritual experience. This suggests the ancient architects cared not only about visual aspects, but also the sound experience within sacred spaces. Angkor Wat also demonstrates advanced water management techniques. The complex includes an elaborate system of artificial lakes, barrages, canals, and reservoirs to control water during the rainy season and provide water for cultivation during the dry season. The largest lake, Western Barrage, measures 5 by 1.4 miles and could hold up to 10 billion gallons of water, an astonishing hydraulic engineering achievement for the 12th century. Modern technical analysis shows this hydraulic system served not just practical needs, but was designed with profound spiritual significance. The lakes symbolized cosmic oceans, and water flowing through channels represented the circulation of cosmic energy. Interestingly, studies by modern meteorologists suggest this massive lake system may have impacted the regional microclimate, creating more favorable conditions for agriculture. Sadly, after the kingdom's golden age, Angkor was gradually abandoned and reclaimed by jungle. When a European explorer rediscovered it in 1860, he described Angkor Wat as a masterpiece of art and architecture, no less remarkable than the finest works that Greece and Rome have left. Today, LiDAR, light detection and ranging, technology has helped archaeologists discover that Angkor was actually much larger than previously thought. Beneath the jungle canopy covering this complex lies a vast urban network of roads, canals, and settlements extending over 1,000 square kilometers, making Angkor one of the largest pre-industrial urban centers ever to exist. Other unique Asian wonders, from tombs to lost cities, the vast Asian continent harbors many other architectural wonders worth mentioning, each with unique technical and cultural characteristics. Let's explore some additional masterpieces to complete our list of Asia's 7 ancient wonders. A white marble mausoleum in northern India is famous for its perfect symmetry and sophisticated construction techniques, completed in the 17th century. Built as a symbol of eternal love, this structure features unique architectural elements. The minaret towers at the 4 corners are designed to tilt slightly outward, a clever design ensuring that in the event of an earthquake, they would fall outward rather than onto the main tomb. Did you know the construction of this mausoleum employed over 20,000 workers for 22 years, with enormous quantities of marble transported from over 185 miles away by 1,000 elephants? Modern acoustic studies have discovered that the main dome can produce an echo effect lasting exactly 28 seconds at a specific frequency, believed to be the frequency of sacred meditation sounds in the local tradition. Particularly impressive is the gemstone inlay technique used throughout the structure. The artisans used the Petra technique, the art of gemstone inlay from Italy, but developed it to an entirely new level. They inlaid more than 28 different precious and semi-precious stones into white marble, creating intricate patterns with astonishing precision. The inlaid stone pieces were polished so thin that light could pass through them, creating a sparkling effect as light changes throughout the day. The world's largest Buddhist temple, at Borobudur in Indonesia, is another astonishing architectural wonder. Built in the 9th century, Borobudur isn't just a temple, but a massive three-dimensional mandala, a cosmic symbol in Buddhism. The temple consists of 9 levels, with 6 square lower levels representing the material world, and 3 circular upper levels representing the spiritual realm. With 504 Buddha statues and 2,672 intricate relief panels, the total length of these reliefs, if placed end to end, would be 3.5 miles. These reliefs tell the detailed life story and teachings of Buddha, forming a gigantic stone textbook of Buddhism. What makes Borobudur particularly impressive is its construction technique. The monument was built without mortar, with over 1.6 million stone blocks joined together using an intricate system of interlocking joints and grooves. Additionally, ancient engineers designed a sophisticated drainage system consisting of 100 spouts and underground stone channels to protect the structure from flooding during the rainy season. But most amazing, this entire structure was buried under volcanic ash and jungle, completely forgotten for nearly 1,000 years before being rediscovered in 1814. The Great Stupa at Sachi, India, is one of the oldest surviving Buddhist structures, initially built in the 3rd century BCE. This stupa, with a diameter of 118 feet and height of 54 feet, is surrounded by a stone railing and 4 elaborately carved gateways, toranas. These toranas are sculptural masterpieces depicting Buddha's life and previous lives, Jataka tales. What's special about the Great Stupa is that it contains no images of Buddha in human form, reflecting the early phase of Buddhist art, when Buddha was represented only through symbols like the Dharma wheel, Bodhi tree, footprints, or empty throne. Modern researchers believe the stupa's structure has acoustic calculations to facilitate meditation activities, with the curved surfaces creating special sound reflection patterns. Finally, the Bagan Plain in Myanmar, with over 3,800 Buddhist temples, stupas, and monasteries spread across an area of 40 square miles, is one of the world's most impressive religious architectural landscapes. Built primarily from the 11th to 13th centuries, Bagan was once the political, economic, and cultural center of a kingdom, where Theravada Buddhism was firmly established. Amazingly, at its peak, Bagan had up to 10,000 religious structures, the highest density of temples in the world. Over a 250-year period, a new temple or stupa was completed every 2 weeks, a testament to the extraordinary devotion and economic power of this kingdom. Recent LiDAR scanning technologies have revealed thousands of buried structures yet to be explored, suggesting this complex was actually much larger than what we can see today. Each structure in Bagan demonstrates the unique development of Myanmar's Buddhist architecture, from bell-shaped stupas to square temples with thin, soaring spires, from simple monasteries to complex structures with maze-like corridors and rooms. Bagan is a living encyclopedia of religious architecture. Particularly impressive is a temple with 4 giant standing Buddha statues, each 31 feet tall, facing the 4 directions. Ancient engineers in Bagan developed many advanced construction techniques, including the use of pointed arches and corbelled vaults to create large interior spaces within temples. They also used a special mortar containing palm sugar, eggs, and other organic components to enhance structural durability against earthquakes, a frequent hazard in this region. The uniqueness and sustainability of Asian wonders, secrets transcending time. What makes Asia's ancient wonders sustainable across time, while many modern structures have significantly shorter lifespans? Modern scientific studies have uncovered many secrets behind this remarkable durability. First is the profound understanding of local materials. Ancient builders didn't just use what they had. They deeply understood the unique properties of these materials and how they would react to environmental conditions over time. For example, the rice mortar used in the Great Wall wasn't just a practical solution, but provided superior bonding strength thanks to the special molecular structure of rice proteins. Modern chemical analyses have discovered that many ancient building materials possess self-healing capabilities, the ability to repair small cracks over time. For example, lime mortar used in many ancient wonders can absorb CO2 from the air over time, creating new calcite crystals that fill microscopic cracks. Material scientists are currently trying to replicate this feature for modern construction applications. Did you know? Ancient structures were often built with fundamental mathematical ratios to make them more durable over time. Many Asian wonders were constructed with dynamic equilibrium proportions, design principles allowing structures to distribute stress and adapt to forces like earthquakes. This contrasts with many modern structures built to be rigid and fixed, making them more vulnerable to damage from vibrations or earth movements. Second is the long-term vision in design and construction. Ancient engineers didn't build for their lifetime, but for future generations, and even for eternity. For example, Angkor Wat was constructed with stone blocks weighing up to 1.5 tons, fitted tightly together, creating an almost monolithic structure that could stand firm through centuries. In contrast, many modern structures are designed with planned obsolescence of just from 50 to 100 years. Modern studies of ancient construction technologies have discovered that many ancient wonders were built with profound understanding of seismic engineering. For example, temples in Bagan were constructed with brick layers arranged in spiral patterns, creating structural flexibility, allowing the building to withstand earthquakes without collapsing. Similarly, towers at Angkor Wat were built with controlled elasticity structures, permitting small movements in individual stone blocks without damaging the overall structure. The third aspect is the harmonious integration of practical function and symbolic meaning. The Great Wall isn't just a defensive structure, but a symbol of strength and unity. Angkor Wat isn't just a temple, but a cosmic model. Petra isn't just a city, but a natural fortress and spiritual center. This combination of practical purpose and deeper meaning has inspired generations to maintain and protect these wonders. Do you see something worth contemplating? While modern buildings are constructed with advanced technology, but often designed with planned lifespans of just from 50 to 100 years, ancient structures have stood for thousands of years despite being built with primitive technology. This paradox reveals a fundamental difference in building approaches. Modern structures often emphasize short-term cost efficiency, while ancient wonders emphasize timeless durability. Have we lost something valuable in our modern construction approach? A surprising discovery from modern archaeological studies is the deliberate over-engineering method applied in many ancient wonders. Ancient engineers often built structures much stronger than practically required, not because they didn't understand structural mechanics, but because they intentionally created wide safety margins to deal with unexpected events like earthquakes, floods, and wars. For example, the walls of many temples at Angkor are from 2 to 3 times thicker than purely structural requirements would demand. Finally, another important aspect is humility before nature. Rather than trying to completely conquer nature, like many modern structures, these ancient wonders often worked in harmony with their surrounding environment. Petra utilized natural rock faces. Angkor Wat integrated lakes and canals into its overall design. The Great Wall follows the natural contours of mountain ranges. This cooperation with nature has helped these structures withstand the impacts of time and climate. Lessons from ancient wonders, messages for the future. When examining Asia's ancient wonders, we're not just admiring past achievements, but extracting valuable lessons for the present and future. What messages do these masterpieces convey to us? The first and perhaps most important lesson is about long-term vision. These ancient civilizations built not just for their current generation, but for thousands of years into the future. In our modern world, where immediate satisfaction and short-term profits are often prioritized, this is a powerful reminder about the importance of building with a far-reaching vision. Modern cost-benefit analysis typically prioritizes short-term outcomes, but ancient wonders demonstrate the value of investing in long-term sustainability. For example, Economists have calculated that the Great Wall's construction cost was equivalent to about 30% of the annual GDP of the empire during its building period. But this structure served defensive, commercial, and cultural purposes for over 600 years, generating value far exceeding its initial cost. Have you ever thought about this contrast? Most modern structures are designed with lifespans of about from 50 to 100 years and are often demolished afterward, creating enormous construction waste. In contrast, ancient wonders were designed to last forever and were typically repaired, renovated, and reused across many centuries. In our current climate and resource crisis context, could we learn from this sustainable approach? The second lesson concerns the balance between technology and nature. Ancient wonders demonstrate harmonious integration between human creativity and natural power. Rather than imposing will upon the environment, ancient architects typically worked with natural conditions, utilizing terrain, climate, and local materials. For example, the builders of Petra didn't fight against the desert, but developed systems to collect every precious drop of water, transforming a harsh environment into a thriving city. Modern sustainability studies have confirmed that many techniques used in ancient wonders can be applied to address today's environmental challenges. For example, Angkor's hydraulic system, capable of managing water in both flood and drought seasons, is being studied as a model for modern climate adaptation solutions. The third lesson involves the integration of practical function and spiritual meaning. Ancient wonders weren't just useful structures. They expressed humanity's deepest aspirations, connecting the material world with higher ideals. Angkor Wat isn't just a temple, but a cosmic model. The Great Wall isn't just a protective barrier, but a symbol of national unity. In a world where architecture is often reduced to pure functionality or external aesthetics, ancient wonders remind us that the greatest structures are those that can address both material and spiritual human needs. Can we create spaces that are not just efficient, but meaningful, not just impressive, but inspiring? The final lesson is about collective cultural heritage. Ancient wonders aren't the achievements of individuals, but of entire civilizations. They represent the coordinated effort of thousands, even millions of people across generations, all working toward a common goal. In our highly individualized era, this is a powerful reminder of what humans can achieve when united for a purpose greater than themselves. Sociological studies of large-scale construction projects have identified that ancient wonders typically resulted from a sense of collective purpose, a shared sense of mission transcending social and temporal boundaries. In our era, as we face global challenges like climate change, can we recapture this sense of collective purpose? Conclusion: ancient wisdom in the modern world. As we conclude our exploration of Asia's 7 ancient wonders, we can't help but marvel at the extraordinary achievements of our ancestors. From the stone dragon winding through mountains in the east, to the rose-red city carved into cliff faces in the Middle East, to the majestic temple complex amid Southeast Asian jungles, these wonders aren't just spectacular architectural structures, but windows into the wisdom and creativity of ancient civilizations. These wonders demonstrate that even without modern machinery, our ancestors could achieve extraordinary architectural feats through a combination of deep scientific knowledge, sophisticated technical skills, powerful social organization, and visionary thinking. They possessed profound understanding of materials, mechanics, astronomy, and hydraulics, proving that human intelligence isn't a recent development. In our modern world, where we often pride ourselves on technological progress, these ancient wonders humble us. They remind us that not all progress is linear, and that in some areas, ancient civilizations may have understood more than we've assumed. This isn't to suggest an idealized mythical past, but to recognize that human knowledge can develop in complex and sometimes unpredictable ways. Looking toward the future, these ancient wonders pose profound questions. Which structures from our era will survive 1,000 years from now? What will we be remembered for contributing to humanity's architectural heritage? Facing global challenges like climate change and resource scarcity, can we learn from our ancestors' sustainable wisdom? Perhaps the greatest value of these wonders isn't their beauty or technique, but the hope and inspiration they provide. They prove that humans, working together with vision and determination, can create works that survive the test of time, even outlasting the civilizations that created them. In an age of seemingly insurmountable global challenges, this is a powerful reminder of our capability and potential. Asia's ancient wonders aren't just relics of the past, but beacons for the future, illuminating the path forward with wisdom accumulated over millennia. As we admire these achievements, we're connecting not just with our past, but with humanity's limitless future potential.